Today, we need to take a look at feeding this poor little giraffe that's stuck out here in the middle of the ocean. We got to get him some food somehow. We're going to do that through this airplane right here. Now, this airplane is traveling at 36 meters per second. Okay, so we're flying through here. We're going to drop this crate full of giraffe food onto this island. Now, here's the options. Here's things that can happen. We can drop the giraffe food too early and it's going to land in the ocean. Giraffes can't swim. Not good. We can drop it on the giraffe, killing the giraffe, breaking his big old long neck. Also not good. We want to drop it perfectly right in front of him. So we need to figure out where we need to drop it as far as like what the momentum is going to be when it hits in order for us to do it right here for the giraffe. So we're working on momentum, we're working on angle for our giraffe food. So here's what's going down. We have a plane that's moving at 36 meters per second. So when we drop this crate, we know from our previous chapter that when we drop things, it is going to move at the same horizontal velocity as what we did before. So you'll notice my vectors here. We have a constant vector line there. Okay, so we're moving. Things are going good. Now, we also know that our vertical vectors are going to be increasing due to gravity. So we're dropping. So we're seeing this increase here. Now, the only thing that we're worried about as far as the fall here is we're worried about how fast this object is going to be right down here at the bottom. Okay, so we have an equation to figure out how fast it's going at the very bottom. So we go to our kinematics. Now the kinematic equation we want to use is going to be v squared equals v naught squared plus 2ad. Okay, so when I do those, the things that I know acceleration. Okay, that's an easy one. Okay, because that's our 9.8, that's our gravity. So we start off by falling, and this is going to be 19.6. We just get rid of that 2. We just multiply the 9.8 times 2, put it in our equation. Now, the d, I don't even know why I wrote that in there. We know what d is. Our plane, Zach, you want to get a nice little close up here? Our plane is 63 meters up. Low flying plane. So we have a 63 meters right there. Now we're going to add that to our initial velocity. Now the initial velocity when we drop it, it's not going to be our horizontal velocity, it's going to be our vertical component. So when we first drop it, it's going to be 0. Scoring a 0 is really easy work. And then we've got our final velocity, which is what we're solving for. We're going to square that. So we drop it down. We figure out the work on this. 19.6 times 63. I've got my magical calculator right here. It's already done for me. And I figure out that I have 35.1 meters per second. So the 35.1 meters per second is my velocity at the very bottom, down here, right when it hits. Now, I don't want to know what the vertical momentum is. I want to know what is the momentum here. Okay? So we're worried about that last little bit. We're not worried about the overall. That would give us the wrong answer. We're worried about the last bit, right as it hits. So what I can do, though, is I can still draw my vector diagram. For that last little bit, we know that it's pushing horizontally at 36 meters per second. That is what we had at the very beginning. Don't confuse that with the problem we just solved for. Okay, that is our vertical component. Okay? So we solve for that. Okay, we just make another triangle. So I'm going to make our triangle right here. We solve for our resultant force, and what we have here, or not resultant force, is resultant velocity. And we have 50.5 50.3 meters per second. We just get that through the Pythagorean theorem. Piece of cake. So we are going at 50.3 meters per second right here. Okay. Now, that is our velocity. That is how quickly it's coming in here. I don't want to know velocity. I want to know the momentum of that box hitting. So, in order to figure out the momentum, we need to first off remember what our equation is. Let's get rid of this little guy right here because I've got that number there. We need to know the equation P equals mv. Okay, so if momentum equals mass times velocity, we know the velocity of the box is 50.3 meters per second. What we don't know, though, is the mass of the box. What we have, though, is we have a force. Our force is 173 newtons. Okay, this is where people start getting confused and they start throwing this number in here for mass. Okay, this is Newton. It's a force. Remember, force equals mass times acceleration. So, what we need to do is we need to take our force of 173 newtons equals our mass, which we don't know, times our acceleration of 9.8. When we do that, we can solve for our m, and our m is going to be, I have to use my actual calculator now. .7 kilograms. Okay, we can plug that into our mass right here. 17.7 kilograms times our velocity of 50.3, and we get a momentum of 888 kilogram meters per second. Okay, that's our momentum. Now we need to know what angle is coming in. So what is this angle right here? Okay, how we're going to do that is we know, back over here. We know our component here is, what was that component? 36. And we know this side is 35.1. Alright, if we do the inverse tan of opposite over adjacent, that will give us our angle. Write it big. Coming in at 44.3 degrees. Alright, we've saved the giraffe today. We're going to go back. We're going to get a couple more problems the next couple of days. Make sure you get your labs done. We'll see you guys tomorrow.